So now we have seen the electric current. Next we will move on to the Wheatstone bridge. So we can see here the overview of the Wheatstone bridge. We will be seeing the definition, who invented the Wheatstone bridge, the construction, the principle and the proof. So first let's see the definition. So basically Wheatstone bridge is used to find the unknown resistance, and it is an arrangement of 4 resistors which is used to determine one of the resistance quickly and accurately in terms of the remaining 3 resistors, and it is invented by the English physicist Sir Charles Wheatstone in 1843. From this we can know that from his name only given the name for this Wheatstone bridge. So this is the diagram of the Wheatstone bridge. So here we can see the 4 resistors P, Q, R and S, and A, B, C, D is the arms of quadrilateral, and here Q is the unknown resistance, and G is the sensitive galvanometer. Galvanometer is the device which is used for calculating the electric current flowing in a conductor, and here S is the standard arm, and here is the battery. So the construction is the same, that is the 4 resistors P, Q and R and S, and arms of quadrilateral A, B, C, D, and the battery between A and C junction, and the sensitive galvanometer between the B and D. So now what is the principle of the Wheatstone bridge? Here the ratio of their resistance is equal and no current flows through the circuit, it is a balanced condition when P by Q is equal to R by S. When the resistance P by Q is equal to R and S, then the galvanometer, when the current flows through the galvanometer, it is 0. And next we move on to the proof part. So first here is the diagram. PQRS is the 4 resistance. By starting with the Kirchhoff's second law, the second law is the algebraic sum of the EMF of potential difference in any loop of a circuit is equal to the sum of the products of current and resistance in it. Here we can see EMF E is equal to V plus IR, and here V can be 0 or E can be 0. Therefore, we will be getting V is equal to IR or E is equal to IR, and here it depicts the summation of the EMF is equal to summation of the product of the current and the resistance in it. And if the potential is equal to 0, then this law can be used. So let's move on to the next proof part. So first let's take the loop 1, that is A, B, D and A. Here we are using V is equal to IR, that is the Ohm's law. So they have given us V is equal to 0 here. So we will be using 0 here. So okay. From A to B, the current I1 flows on. So it is I1P. It is towards the junction, so plus sign. And from B to D, the current flows to the galvanometer, that represents as Ig into G. So it also towards the D junction, so plus IgG, and small g into capital G. And when it flows from D to A, it is the current is flowing in the opposite side. You can see that I2 is in this side and it's not moving in this side. So sorry, from D to A it's not moving, it's moving from the A to D. So away from, if the current is flowing away from the junction, it can be represented as minus sign. So this is the first loop in the clockwise direction. And what this loop means, it has the same start and end point. Here we can see A, B, D, A. So if the loop has the same start and end point, here we can see A, B, D, A. A and A are same. So the next loop is B, C, D and B. Here also the same. but here they haven't given the current properly, so we have to find the current. So the current flows from A to B is I1 and B to D is IG. So second loop, here it flows from A to B and B to D. So here the remaining current will be I1 minus IG, and here it flows from the C to D and D to B. Here it comes as I2 plus IG, and it is the opposite direction, therefore it is minus IG into capital G. So this is also in the clockwise direction. So according to according to the principle, when the bridge is balanced, we know that Ig is equal to 0. So here BCDB, the current flows from B to C, that is I1 minus Ig, and from C to D it is I2 plus Ig, and B to D it is in opposite direction, so we have considered it as minus Ig into capital G. So we can continue here. Here when the bridge is balanced, then Ig is equal to 0. We have already seen in the principle. So when Ig is equal to 0, there is no current flowing, then it doesn't show any deflections. So let's take the first equation here. From the first equation, I1P plus Ig capital G minus I2R is equal to 0. We know that Ig is equal to 0, so this will be cancelled and we will be getting I1P minus I2R is equal to 0, where this goes that side, and we will be getting I1P is equal to I2R as the third equation. And from the second equation, I1 minus Ig into Q minus I2 plus Ig into S minus I small g into capital G. Here I small g into capital G will be 0.
What is Ig?
The current flowing through the galvanometer.
What is G? Capital G?
Galvanometer.
Galvanometer resistance. So the resistance of the galvanometer, here it is represented as G, capital G, uppercase G, right.
Okay. So when we internal multiply, we will be getting I1Q minus IGQ minus I2S plus IGS minus Ig into capital G. Here when Ig is equal to 0, we will be cancelling everything, and we will be getting I1Q minus I2S is equal to 0, and we will be getting the I1Q equal to I2S as the fourth equation. So we have the third equation and the fourth equation. So from third and fourth equation, we will be getting I1P is equal to I2R and I1Q is equal to I2S. When they both are divided, that we are getting the ratio as P by Q is equal to R by S. It is the balanced equation as we see the principle before. So this is the proof of the Wheatstone bridge. Then we have a sum here. The four arms of a wheat bridge have the four resistance. AB is equal to 100 ohm, BC is equal to 10 ohm, CD is equal to 5 ohm and DA is equal to 60 ohm. The galvanometer of 15 ohm resistance is connected across BD. We have to calculate the current through the galvanometer when the potential difference of 10 volt is maintained across AC.
So when you solve the problem, you have to represent the diagram first based on the problem, visualize it, then write down all the parameters given, then what are asked, then what is the equation to be used, and substitute and get the answer. Okay, this is the way you have to approach. Right, proceed. Now you can keep it here. No, you need not draw. Straight away you can proceed.
Sir,
So I am representing here, no problem.
sir, how can I explain, sir?
You can explain based on the diagram.
So they are given are AB is equal to 100 ohm, BC is equal to 10 ohm, CD is equal to 5 ohm, and DA is equal to 60 ohm, and the galvanometer is 15 ohm, and we have to find the IG. And here also you can see the diagram. So first we are taking the loop A, B, D and A. This is the first loop we are taking. So from this, before we saw the proof, from the loop A, B, D, A, we are using here V is equal to IR or E is equal to IR, where E is equal to 0. So 0 is equal to here 100I, 100I1 plus 15 IG minus 60 I2, that is from A to B is 100 I1 and B to D is 15 IG, and from D to A it is in the opposite direction, that is minus 60 I2. It can be further simplified as 20 I1 plus 3 IG minus 12 I2. This will be our first equation. So next we are taking the second loop, that is DC, DB. Here also that E is 0. So we will be getting 10 into I1 minus IG minus 5 into I2 plus IG minus 15 IG. So from BC, D and B, 10 into I1 minus IG. From C to D is I2 plus IG into 5. It is the opposite direction, so minus, and here minus 15 IG. So 10 I1 minus 10 IG minus 5 I2 plus 5 IG minus 15 IG. So we will be getting 10 I1 minus 30 IG minus 5 I2. This can be further simplified into 2 I1 minus 6 IG minus I2. This is the second equation. As they are given us, we have to take the 10 volt from the galvanometer. We are taking the another loop, that is A, D, C, E from the battery and again to A. So the loop A, D, C, E and A, we will be getting 10 is equal to 60 I2 plus 5 into I2 plus IG, which is 60 I2 plus 5 I2 will be getting 65 I2 plus IG. This can be furtherly simplified into 13 I2 plus IG is equal to 2. So this will be our third equation. So we are going to solve these three equations. We will be getting the value of the IG. So first we are taking the equation 1 and 2. That is 20 I1 plus 3 IG minus 12 I2 is equal to 0 is our first equation, and second equation we are multiplying it to 10. So we will be getting 20 I1 minus 60 Ig plus 10 I2 is equal to 0. When we sign these changes, when we change the sign, this will be cancelled and we will be getting 63 Ig minus 2 I2 is equal to 0 as the fourth equation. And when we solve the when we take the fourth equation, 63 Ig minus 2 I2 is equal to 0, and the equation of the third and fourth equation, Ig plus 13 I2 is equal to 2. This is this is fourth equation and this is third equation. Here we are multiplying the old equation into 13. So we will be getting 819 Ig minus 26 I2 is equal to 0, and here
Ig plus 13 I2.
This also we have to multiply into 2. So we will be getting 2 Ig plus 26 I2 is equal to 4. Here plus and minus are there, so we are directly cancelling. So we will be getting 821 Ig is equal to 4. So Ig is equal to 4 by 821, where we will be getting the answer as 2 by 410.5 ampere. So therefore the value of the Ig, that is the current flowing through the galvanometer, is 2 by 410.5 ampere.
You can maintain as a 4 by 820.
Okay.
You need not put a fraction as well as decimal. You can erase this one, second part.
So finally we got the answer as for the current through the galvanometer when potential difference of 10 volt is maintained across the AC, we will be getting the answer as
4 by 8.
4 by 821 ampere.